We are going to talk about table probabilities, and really the conditional probabilities are the trick. These are not conditional probabilities, and they should be really easy. What's the probability out of these 215 people that I surveyed, and I asked them, what year in school are you, and how do you get to school? What's the probability that if I randomly picked one of these 215, I would get a freshman who rides their bike? Well, it's out of 215 total. The number of freshmen who ride a bike is 5. So 5 out of 215. Now, if I just wanted to do what's the probability of a freshman, I would look at how many freshmen total are there. I would add all these numbers up, which gives me 24. That's 24 out of the 215. What's the probability of picking someone who rides a bike? I would add up all these bikers. That's 52. So that's 52 out of 215. Now, if you recall from the rules of probability, you should be able to get this same number by taking the probability of freshmen times the probability of bikers. That's only true if it's independent, and in this case it's not. So timesing these guys together will not give you the 5 out of 215, which you can't see because there's a glare right on my board. That's annoying. Okay, that's not what this video is about. This video is about the trick of conditional probabilities. Questions like this. We have here, what's the probability that we randomly select a freshman if I know beforehand? This line here means given that they are a bus rider. So here's the scenario. There's 215 total people, but I tell you I picked someone who does ride the bus. Now, what's the probability that they're a freshman? So the way you handle these conditional probabilities, it's called conditional because we want the probability of a freshman conditioned on them being a bus rider, is you take away everything that's not part of the condition. Let's take away everything who's not a bus rider. So I have here my evil red marker. Allie, come take away everything that is not a bus rider. Okay, so, okay. Good job. So what Allie has left me with is all my bus riders. There's 65 of them. So my total is no longer 215. She burned all these other categories. It's now a total of 65. Out of those 65, how many were freshmen? Only 7. So my answer is 7 out of 65. Notice when you're given information, it changes the total. It's not 100% anymore, it's only that 65. Let's try the next one. Allie, come get the red marker. This time, I know they're a sophomore or a senior. So Allie, I want you to burn everything except not sophomores and not seniors. Good. So what did Allie leave us with? Well, my total is no longer 215. She burned these 80 and those 24. So what's left? Well, I have 46 and I have 65. So 46 and 65, that's my new total. And the question is, how many of them are car riders? Well, I have 20 and 18. So 20 and 18. If I simplify those, 20 and 18 is 38. And 46 and 65 is 111. Yes. So that's my new probability. My 111 represents the sophomores or seniors. Let's make this really hard for Allie and see if she can still do it. We are now talking about, I'm going to randomly select a student. And I'm going to avoid anyone who rides a bike or a bus. And I'm going to avoid anyone who's a junior, for some weird reason. Now, what's the probability that my randomly selected person is a freshman or a sophomore? You ready, Allie?
And the juniors.
Go for it. So who did Allie burn? She burned anyone who's on a bike because she knows we didn't pick them. We didn't pick anyone on a bus, and we didn't pick anyone who was a junior. So this is what's left of my table. So what is my new total? it's not 215 anymore. The easiest way to do this might just be to count up how many cells are left. My new total is 37, 47, 55, 65, 69. So I now have a total of 69 people, and what do I want to know? How many of them are freshmen or sophomores? Well, I have these 37. So my answer is 37 out of 69. With a table, it's not hard to do conditional probabilities. Burn the stuff that isn't relevant to what you're talking about, and then count up the stuff that you're wanting the probability for.